Hi there, welcome to another video. Today I'm going to talk to you about simplifying rational expressions. Okay, so there's lots of kind of different states that we can start with in terms of what the rational expression looks like. Okay, a rational expression is basically any number, a set of numbers that's being divided by a set of terms or a term with a variable in it. So for example, 3 over x is a rational expression, or like 5x minus 2 over 3x. So these all have variables in the denominator here, so they're called rational expressions. A rational expression would not be something like 1 over 4. Okay, this is called a fraction, but there's no variable in the bottom, so it's not a rational expression, okay? And as you can imagine, rational expressions can get pretty ugly. Like this is kind of showing you how they can get a little harder from just something like 3 over x, and this right here isn't the hardest it can get, trust me. So we're going to go over some more difficult examples, and when the questions get longer, it becomes a bit more necessary to simplify when you can. So we're going to be able to simplify by factoring in lots of examples, by factoring and crossing out what we see on the top and the bottom. If they're multiplying or if they're subtracting or adding, we can work with that too. I'll show you how to do it right now. So the first example I want to do is going to involve multiplying rational expressions. Okay, so let's say we had something like x squared minus 25, okay, divided by x squared minus 4x. Okay, how could we simplify this? So x squared is a perfect square, 25 is a perfect square, so we can use our difference of square factoring method to factor the top. Okay, so we get x plus 5 over x, or times x minus 5, and we're going to divide that by the factored form of the bottom. So we can take out an x, right, because they both have an x, and we get x minus 4 here. So the next thing we have to do is we have to ask ourselves if we see anything on the top and the bottom that we can cross out. For example, if we had x plus 5 times x minus 5, and instead of 4, this was x minus 5, right? If we have something times x minus 5 on the top, and we're dividing it by x minus 5 on the bottom, that's kind of an inverse operation, so we could cancel, but that's not the case because instead of 5, this is a 4. So we can't simplify this anymore, and if you had this on a test or a quiz, this would be all you could do to simplify, okay? But what if the question wasn't just x squared minus 25 over x squared minus 4x? What if they added another kind of set of terms to multiply by, which is, I don't know, x squared plus x minus 20 divided by, let's say, x squared plus 10x plus 25. Okay, now let's factor the right side here. So on the top, we need two numbers that multiply to negative 20 and add to positive 1, right? Because there's that imaginary 1 in front of the x. So that's going to be, let's see, x, 5 and negative 4 should work, right? Those multiply to negative 20 and add to 1. And now we can already see that there's a 5 or a x minus 4 on the top and the bottom, right? So now let's do the bottom here. We need two numbers that multiply 25 and add to 10. That's going to be 5 and 5, so that's a square as well. Okay, so now is the fun part. Now that we did the hard part of factoring, the fun part is just crossing out what we see on the top and the bottom. So there's an x minus 4 on the top and the bottom, cross that out. X plus 5 on the top and the bottom, right? X plus 5 on the top and the bottom here. And all that we're left with is going to be x minus 5 divided by x. Okay, and I just want to be clear, this isn't the exact same thing as what we started with because there's something called non-permissible values, where basically there's values for x that we put in where it could make the bottom 0, and in math, the denominator can never be 0. Okay, so the NPVs, or non-permissible values, for what we started with will be different than what we ended with. So it's not the exact same expression, but I'll go over that in a separate video, so don't worry about that for now. This is just how we can simplify long, ugly sets of terms like what we started with and kind of condense it into something like x minus 5 over x. It's a bit easier to work with. So it's not exactly the same. There's some differences when you graph them, but don't worry about that for now. So let's do an example where instead of multiplying everything, we're dividing. So let's say we have 5x squared plus 15x plus 10 divided by, let's say they already gave it to us. Let's say that it's x plus 3 times x minus 4. Okay, and let's say we're dividing that, got a divide sign here, by x plus 2 squared over 2x minus 8. So for this one, they made it a bit easier. They gave some things in factored form, some things we still have to factor, but the main difference is that now there's a dividing sign. So we can't just jump right into factoring and crossing things out because that only works when everything's multiplying into each other, right? If we see something on the top and something dividing on the bottom, we can cross that out because there's that multiplication sign, but that's not going to work when we're dividing. So the first thing we do before we factor anything is we rewrite what we have on the left, 5x squared plus 15x plus 10 over x plus 3 times x minus 4. Okay, that stays the same. And when you watch my other videos on how to combine fractions, how to add or subtract or multiply and divide, whenever we have this dividing symbol between two sets of fractions and we want to make it multiplication, we say dividing fractions is as easy as pi. We flip the second and multiply. Okay, so flip the second means we flip the second term, the second fraction. We take its reciprocal and we just multiply them. So now this is a times. Now this 2x minus 8 is going to go to the top. So we're taking the reciprocal of the right side, and the x plus 2 squared is going to go in the bottom. So we flipped the second and we multiplied. Okay, and now this is exactly like we had in the other question. We have a fraction or a rational expression on the left, and we're multiplying by another rational expression on the right. So now let's kind of start to factor this. So I see a common factor here of 5 for the top left, right? Each term has a 5 in it. So if I factor out a 5, I'm left with x squared plus 3x plus 2. And I'm going to divide it. Right? I'm going to divide it by x plus 3 times x minus 4. Okay, and we still have that times sign in here. I see a common factor of 2 for the top right. They both have 2 in it, so I'm going to factor that out. That's going to be x minus 4, right? Because if I distributed this 2, I could just get 2x minus 8 back. And now I'm going to divide that. X plus 2 is already in factored form. I'm just going to rewrite it as x plus 2 times x plus 2. So it's a bit easier to kind of cross things out once we factor the top left here. So let's factor x squared plus 3x plus 2. We need two numbers that multiply to 2 and add to 3. So that's going to be positive 2 and positive 1. All these questions look kind of hard because there's so much writing, but over half of it is just rewriting what you did in your head, right? So we get x plus 2 times x plus 2. All right, so now we have everything factored. We have this multiplication sign between them, which is awesome. So now all that we are going to do is cancel what we see on the top and the bottom, the fun part. So I see x plus 2 on the top and bottom. I see x minus 4 on the top and the bottom. And that looks like it's it. So now we see that there's a 5 and a 2 being multiplied. So that's going to give us 10, right? We can multiply those. We have this x plus 1 that's still kind of hanging out. It's not on the bottom to cancel, so we have to leave it. And the only thing left on the bottom is this x plus 3. So let's have x plus 3 on the bottom there. So this is kind of the simplified version of what we started with. It's not super pretty itself, but it's much better than this whole fiasco up here. So like I said, this isn't the exact same as what we started with. The non-permissible values will be different. Okay, but like I said, I'm going to go over that in a separate video. So that's how you can multiply and divide rational expressions. Now let's go over some examples. Or actually, let's do one more involving more variables. Okay, so let's say we have x squared divided by 2xy squared, right, divided by, let's say y over 3, actually no, let's do 6x. Okay, so we have two kind of sets of rational terms and we're dividing them, so let's make this a multiplication first by flipping the second and multiplying. Okay, so we have x squared over 2xy squared. Keep that the same, and we're going to multiply by 6x over y. Okay. Now we're just going to cross out what we see on the top and the bottom. So there's an x on the top here and an x on the bottom there. And it looks like that's all we can cross out in terms of variables. So we're going to have that 6 left over times x squared divided by 2y squared. Okay, and we're not quite done yet because the 6 and the 2 have a common factor of 2. So if we can simplify and divide the top and bottom by 2, we're going to be left with 6 over 2, which is 3x squared, divided by 2 over 2, which is 1, so that 2 goes away, times 1 squared. So all I did was I just divided, I'll write it on the right side here. I just divided the top and the bottom by 2 to simplify. Okay, so we get 3x squared over y squared. Now let's do some examples where instead of multiplying and dividing, we're adding and subtracting. Okay, so it's not exactly the same, but it's kind of similar. We still have to do that factoring. So let's say we have, I'll draw a line here. Let's say we have x over x minus 2 minus x minus 14 over x squared minus 10x plus 16. Okay, so this is the difference of rational expressions. First thing we always do is we factor. Okay, so we have x over x minus 2 minus x minus 14. So the only thing we can really factor here is the bottom. So we need two numbers that multiply to positive 16 and add to negative 10. That's going to be negative 2 and negative 8. Okay, and then the next thing we have to ask ourselves is if we want to combine these two fractions, right, we want to make them one, these two rational expressions, how can we do that? Well, the common denominator has to be there, right? We can't just subtract x minus 14 from x because this only has an x minus 2. Well, this has x minus 2 times x minus 8. So in order to make the left side have a common denominator with the right, we have to find the lowest common denominator, right? So if we multiply the x minus 2 by that x minus 8, running out of room here, on the top and the bottom, then that will give us that common denominator of x minus 8 times x minus 2. Okay, so on the top we have x minus 8 times x minus x minus 14, and that is all divided by our common denominator, right, of x minus 2 times x minus 8. So we need that common denominator. Once we have it, we can combine the fraction, right, which is what we just did. So now let's distribute this x into the x minus 8, and let's distribute this negative into the x minus 14. So over here, x times x is x squared. X times negative 8 is negative 8x. right? Negative 1 times x is just negative x. Negative 1 times negative 14 is positive 14. And we have that divided by x minus 2 times x minus 8 on the bottom there. Okay, so now we can combine like terms. I see this this negative 8x and this negative x, so we can combine that to make minus 9x plus 14 divided by x minus 2, x minus 8. Okay, next thing, two numbers multiply to 14 and add to negative 9. Right now we're just factoring, so we can kind of cross some stuff out. So that's going to be two negative numbers. So it's going to be negative 7 and negative 2, right? Because those add to negative 9, multiply to positive 14. X minus 2 over x minus 8. Okay. Now we can cross out what we see on the top and the bottom because everything on the same kind of level, everything in the numerator is multiplying, everything in the denominator is multiplying. So inverse operations, we can cancel x minus 2, and we're left with x minus 7 over x minus 8. Okay, so that is the fully simplified version, and like I said, it's not the exact same as what we started with, right? X minus 2, or x over x minus 2 minus x minus 14 over x squared minus 10x plus 16, but it's pretty darn similar. The only thing that's different is when you graph it, you'll see that there's something called a hole in the graph. There's more parts where the function won't exist in what we originally had, but I'll talk about that in another video. So that's how you can subtract two rational expressions or sets of rational terms. Okay, and adding is basically the same thing. All we're doing for adding and subtracting rational expressions or fractions in general is just finding a common denominator and combining the fractions, keeping the denominators the same. So it's the exact same as subtracting, and I hope this video helped you in your journey of trying to figure out rational expressions. It can get pretty tough, but I'm going to go over how we can solve rational equations as well. It's very similar to what we just did. It just has an equal sign in it, right? Because it's a rational equation. And I'll see you in my next video. See you later.